Forget aliens, the sky is falling. Earth on average gets hit by 100 tons of stuff from space every single day. Now, most of the time this stuff is pretty small, dust or space gravel or whatever, but once in a while it's not so small. So let's say you've detected an asteroid and it's on a collision course with the Earth sometime in the next decade. What are our options? Well, they're the Hollywood answers. And those might do in a pinch, but they're not necessarily our best choices. Scientists are looking into other possibilities, like the gravity tractor. Alright, so here's how it works. You've got an asteroid flying in space, and then you fly a probe alongside the asteroid. Now, the asteroid will exert a gravitational pull on the probe, but the probe will also have a slight gravitational pull on the asteroid, and it will slowly and gently pull the asteroid out of its collision course with the Earth. Another option is to actually land a probe on an asteroid and use it to capture a boulder from the asteroid's surface before taking off again. This way, the probe can use some of the asteroid's own mass as a gravity tractor and pull it out of the way. Or, instead of pulling, we could think about pushing. What if we were to land a thruster on the surface of an asteroid so that the exhaust is pointed outward, and we ignite the thruster, turning the asteroid into a very primitive spacecraft and moving it out of that collision course? Or you could put a really reflective material on the surface of the asteroid, effectively turning it into a sort of solar sail, and that way light itself would push against the asteroid. Now, that's not a very strong push, but with enough time, say a decade or so, you could move it a couple of degrees out of the way, which is plenty to make us safe in the long term. In February 2013, the people of Chelyabinsk Oblast in Russia experienced a pretty dramatic event. A meteor 20 meters wide exploded over the region. The explosion caused a fireball seen by thousands of people, and the concussion from the airburst actually punched out windows over a wide area. More than 1,000 people called in injuries, mostly due to lacerations from broken glass. And here's the scary thing about this scenario. Nobody knew it was coming. And that leads us to one conclusion. The telescope is the most important element of planetary defense. Now, NASA already has telescopes in play mapping out near-Earth objects. In fact, they've already identified 13,500 of them as of January 2016. And every year, ground-based telescopes and infrared ones like NEOWISE identify another 1,500. On top of that, other organizations are getting into the game. There's a nonprofit called the B612 Foundation that has the Sentinel project. This involves launching an infrared telescope that will orbit the sun inside of the Earth's orbit and look out for these near-Earth objects. This, paired with a land-based telescope in Chile called the Large Synoptic Survey Telescope, will be able to identify and track 90% of all near-Earth objects that are larger than the one that hit Tunguska, Russia in 1908. That one caused 800 square miles of devastation in the Siberian wilderness. Now, when you're talking about destruction of this magnitude falling literally from the skies, it is natural to feel a little scared and helpless, but this is one case where knowledge really is power. And that leads me to a question for you guys this week. How would you best prepare the Earth for planetary defense from things like asteroids and meteors? I want to hear your ideas in the comments below. Thanks to Toyota for sponsoring the show and making it possible. If you enjoyed this episode, do me a solid and hit that little like button down there. Also, don't forget to join the Forward Thinking Think Tank. It's easy, you just subscribe to this channel. And finally, after all that, make sure you check out these other amazing videos about our future right over here.